All right, well, this is lesson 3 of our nuclear weapons section. You probably saw that an assignment posted this morning. In a little bit, I'm going to have you pause the video and watch the YouTube video about hydrogen bombs and how they differ from conventional nuclear weapons and conventional bombs, or how they differ from atomic bombs. And so we'll kind of get through that a little bit as we go here. So up to this point, we've talked about the discoveries that led to the Manhattan Project, the fission of uranium, the calculation of the amount of energy that would be there. We talked about people like Lisa Meitner, Albert Einstein. We've talked about Enrico Fermi. And then we also talked about the Manhattan Project itself, General Groves, J. Robert Oppenheimer, Glenn Seaborg. We talked about Oak Ridge, Tennessee, Hanford, Washington, and Los Alamos, New Mexico. So in that time, hopefully you've wrapped your brain a little bit around what's happening here. So in Oak Ridge, Tennessee, they're enriching uranium, and they're sending that enriched uranium to Los Alamos, and a little bit of it up to Hanford, Washington. In Hanford, Washington, they're using that enriched uranium to make plutonium in these giant graphite reactors. That plutonium that's being made and purified there is also being sent to Los Alamos. And in Los Alamos, they're building and testing the devices that would eventually turn into nuclear weapons. Throughout the time of the Manhattan Project, from 1941 until 1945, Oak Ridge, Tennessee operated 365 days a year and 24 hours a day. And in that time, they produced enough uranium, enriched uranium, to produce exactly one nuclear weapon. And that's the one you see on the screen here. This weapon was called the gun design. The weapon that was built, that was dropped on Japan, was called Little Boy. And so this was Little Boy. It's not really that little. It's about 10 feet long and about 4.5 maybe 4 feet tall. So it's not that little. It's a very, very large bomb. In fact, it was so large that our bombers that we used in World War II couldn't carry it. It wouldn't fit. And so they had to retrofit airplanes to carry this thing. So the way that's worked was they had 2 sections of uranium. They had a section here of uranium and a section back here of uranium. Now, how it was actually designed, we're not really sure. It was either a cylinder with a hole in it and then a target piece that was shot down to be inserted into that hole, or vice versa, as this picture shows. It shows a target piece and then a cylinder or a piece like that was shot down to go over top of it. But either way, essentially you have 2 pieces of uranium-235 that are not a critical mass. Remember, critical mass is the amount you need to go to get a chain reaction. These 2 together were supercritical. And so supercritical means that there was so much mass there that it wouldn't just carry out a chain reaction, but an exponentially increasing chain reaction. And so the way they designed this is they put a conventional explosive at the back of the bomb, and at about 1,500 feet above the surface of the Earth, the conventional explosive exploded, shooting half of the uranium towards the other half. When they slammed into one another, they became supercritical, and a nuclear explosion took place. And we're talking an explosion that was huge, about 15,000 tons of TNT. Okay, so that's 15,000 tons would be 15 kilotons. At that time, it was the largest weapon ever used in wartime, and we'll talk about that a little later. So this was a very, very simple design. In fact, it was so simple they decided not to even test it because it was such a simple design. The plutonium coming from Hanford, Washington had a problem. The plutonium-239, so Pu-239, had some plutonium-240 mixed into it that they just couldn't get out of it. And the plutonium-240 released too many neutrons, so that when half of it, like in the previous design, was shot towards this half to make a supercritical mass, some extra neutrons, so there were all these extra neutrons, if I can draw a neutron, shooting around in there, and they caused these two halves to actually fire away from each other. Now, they never actually tested that. This was all in theory. So theoretically, because there were too many neutrons, calculations told them that they would not be able to use the simple design of the gun bomb like they did with uranium. Instead, they had to come up with something a little more sophisticated. And so the Fat Man bomb, which was the second bomb designed during the Manhattan Project, had a sphere of plutonium. So here's a sphere of plutonium that was hollow in the middle. And because it was hollow in the middle, it had the right mass to be critical, but not the right density. And the stuff just wasn't close enough together. So they created a spherical set of lenses, explosive lenses, that all blew in the same direction. And so all of these lenses blew inward, and not just in a circle like this, but in a sphere. And they were blowing in from every direction. And what happened was the sphere of plutonium would contract and get very small. And when it contracted down, it achieved critical mass in a fraction of a second, about 600 billionths of a second. And so all of these lenses had to explode at exactly the right time to cause the sphere to contract. If only half of them blew up and the other half, or even one, didn't, the sphere would just be ejected from the device through the lens that didn't explode. And so this was a very, very complex device. During the Manhattan Project, the Hanford, Washington actually produced enough plutonium to build 2 nuclear weapons. So from 1941 to 1945, we produced enough nuclear material through Oak Ridge, Tennessee and Hanford, Washington to build 3 nuclear devices. Because the plutonium bomb was so complex, we had to test it. So the first ever nuclear explosion were not the bombs that were dropped on Japan. In fact, they were an explosion, a nuclear explosion that we blew up right in our own backyard. The gun design was really simple, and scientists didn't think they needed to test it, and they couldn't have tested it if they wanted to because they didn't have any more uranium. The implosion device was much more complicated and needed to be tested. So a site was chosen in the Coronado del Muerto Valley near Alamogordo, I'm probably not pronouncing this right, New Mexico. So it was a place in New Mexico, way out in the desert, and they codenamed the site Trinity. And at Trinity, this is the Trinity site here, they built a huge tower. And on top of the tower sat this freakish looking thing, which was not a bomb. It was a science experiment. A bomb is something that is used to cause devastation, to drop, or to use against an enemy. This could not be delivered. This thing had so many wires and so many things hooked up to it. They had no way they could have used this any other way than just to blow it up and see what happens. So they called this the Gadget. So Gadget was the code name given for the very first device to produce a nuclear explosion. Now, up on top of this tower, Gadget sat up there, but before that, in the area of Trinity, so if this is like a map, they had another tower that they had built. And at the top of that tower, they put 1,000 tons of TNT. And they blew it up, and it made a little crater like this. So it created this big explosion like this. And then several weeks later, they built another tower right next to it, and they put Gadget up there, and they blew it up. And it produced about a 15 kiloton 15 kiloton explosion. Okay, so it produced a massive, massive explosion. So on July 16th, 1945, at 5:29 in the morning, the first ever nuclear weapon exploded, and this is what started the dawn of the nuclear age. And this was in New Mexico, and this is a picture of it. At the bottom of the screen, you can see 100 meters. 100 meters is about that far. All right. So if we expand that out, so in this picture, the shock wave, which is right here, the edge of this. So I'm having a hard time drawing because it's black, but the shock wave is this distance here, which is about 0.5 kilometers, so about half a kilometer. So we have half a kilometer there, and look at the time over here, 0.053 seconds. That is a huge amount of explosion in a very, very short amount of time, and that's actually what does all the damage in a nuclear explosion. Everybody thinks it's the fireball. Well, the fireball doesn't extend very far out from the middle. It's the shock wave that shoots out from a nuclear weapon that does all the damage. So this was the dawn of the nuclear age. This is July 16th, 1945. This is the remnants of the tower. Edward Teller, we're going to learn about him. He's the father of the thermonuclear weapon, which we'll see in a minute. He described wearing double welder's glasses. If you've ever done any welding, you know you can't see through one set of welding lenses, let alone two sets. And he wasn't impressed with the explosion until he removed his hands from the side, from around the outside of the glasses to keep light from coming in the sides. Enrico Fermi was holding pieces of paper in his hand and waited for the shock wave to get to him. He actually looked down at those pieces of paper right as it exploded and missed the initial explosion. And he later commented that he missed fission and the world's first nuclear explosion. As soon as the scientists saw the devastation of this bomb and also where we were with the war, we had pushed the Japanese back all the way to their home island by this point. And so the war in Europe was done in May 8th of 1945. Japan had never been a threat to build a nuclear weapon. The funny thing is Leo Szilard, the guy who wrote the letter to get Roosevelt to start the nuclear program, started a petition to suggest that maybe the bombs should be not dropped on Japan, but maybe used as a demonstration, like drop them just offshore or on an uninhabited part of Japan. General Groves definitely wanted to use the bombs. And when the petition was sent to Oak Ridge, Tennessee, General Groves actually manipulated its delivery to Truman. And so the petition never actually made it to Truman. And President Truman decided to use the bombs. During the Manhattan Project, while the bombs were being built, the 509th Composite Group of B-29 bombers were practicing dropping these big orange bombs that they called pumpkins, and the bombs were the same size and shape and weight of the Fat Man bomb, and so they practiced dropping these pumpkins on different targets so that they would have a good practice for the real thing. Tinian Island is an island that the Japanese took during their conquest of the Pacific, and when we fought back in the Pacific, we actually took over that island, and we took it from the Japanese during World War II. We fought to capture that island, and we built an air base there. And so at that air base, the planes that were going to be used to drop the bombs were housed there, or were taken there. An interesting story is the USS Indianapolis was the ship that was used to carry the bombs to Tinian Island. And after delivering the bombs, both of the bombs to Tinian Island, on its way back, it was actually sunk by a Japanese submarine. And many of the sailors died. Had it been sunk on the way there, about $2 billion in 4 or 5 years worth of work to produce those 2 bombs would have literally gone down the drain. These are actual pictures of the bombs themselves at Tinian Island, waiting to be loaded into their planes. Little Boy on the left and Fat Man on the right. You can kind of get an idea of why they got those names. On August 6, 1945, Paul Tibbets piloted the Enola Gay. The Enola Gay was the name of the plane. In fact, you can go to the hangar at Dulles International Airport in D.C. You can get in for free. It's got lots and lots of famous airplanes, but the Enola Gay is actually there, and you can see the actual plane. It took off from Tinian Island and dropped the Little Boy bomb on Hiroshima, and it had a yield of somewhere between 12 and 15 kilotons. 70,000 people immediately lost their lives in the blast, and another 140 by the end of the calendar year from radiation sicknesses, radiation poisoning, or from their injuries that they sustained during the shock wave. In the background, you can see this building here. That's actually the epicenter. The bomb actually dropped directly on top of that building, and that's the reason the building's standing, because all of the pressure went straight down, and a building is meant to stand straight up and down, so it's very structurally sound there, whereas the shock wave shot out in every direction, leveling everything. These are pictures before and after. So you can see the epicenter right here at the edge of the river right there. You can see all the buildings in this image here, and then in the image to the right, you can see that everything's pretty much been wiped clean. Three days later, after given some time to call it quits, the Japanese didn't surrender. So we dropped another atomic bomb, the Fat Man bomb, on Nagasaki. It was piloted by Charles Sweeney, and the name of that plane was Boxcar. And it had a 21 kiloton explosion. Now, it actually killed fewer people, 40,000 versus 70,000 with Little Boy, and 70,000 versus 140,000 with Little Boy. And that's because you can kind of see in the back, you can see there's a hill here. Nagasaki's a little more hilly. Plus, after word got out about the first nuclear bomb, a lot of people started to leave the cities. We had actually dropped information saying, hey, we're going to bomb these cities to nothing. You need to get out. And people didn't believe us with the first one, and then with the second one. People hopefully started to get a little bit of the message, but still, 70,000 people is a lot of people. Altogether, 210,000 people died from these 2 bombs by the end of the year. That is an astronomical number of deaths from just 2 devices. And so that's why in wartime, the United States is still the only country to ever use nuclear weapons. Just a few days later, Japan surrenders. Good thing, because we didn't have any more nuclear weapons to drop on them. We said we did, but we didn't. The surrender was signed in Tokyo Harbor on September 2nd. After the war, within less than a year after the war, we already started testing new nuclear weapon designs. We took a whole bunch of ships that we had captured from the Germans and from the Japanese as a result of their surrender, and we towed them all to the Bikini Atoll in the South Pacific, and we dropped nuclear weapons on them and blew some up underneath them just to see what would happen in a Pearl Harbor style attack. From that time, from 1946 to about 1972, the United States blew up over 300 nuclear weapons in atmospheric tests. And atmospheric tests means it takes place somewhere out from underground. So it could be space, in the air, on the land, in the water, and we carried out over 300 of those. Edward Teller pushed for further work on nuclear weapons. He says that he did it because he wanted more knowledge, and knowledge was important. However, He was also one that felt like the United States needed to have superiority over other countries technologically, so that played a role too. He's known as the father of the hydrogen bomb. Ullum here recognized that radiation and heat could actually create the pressure needed to carry out nuclear fusion. Remember, fission is the idea you have something big like uranium and you hit it with a neutron, and that neutron splits it into two, releasing energy and more neutrons. So you release a few more neutrons, but you also release heat and light, things like that. Fusion, on the other hand, you have something small like deuterium and tritium, and these get pushed together because of heat and pressure to form a helium plus an extra neutron and a whole lot of energy, like in the sun. Problem is, we don't have a way to produce that heat and pressure, but Ullum was like, hey, wait a second, we produce a lot of heat and pressure when we carry out a nuclear fission reaction. So this led to the design of staged thermonuclear weapons. Thermonuclear means heat nuclear. So it's a nuclear weapon that takes place because of the heat. And so these are what we call hydrogen bombs. So we have atomic bombs, which are like the uranium-235 little boy or the plutonium-239 fat man bombs. But then we have hydrogen bombs. And hydrogen bombs are what we use today. They use deuterium. Deuterium is a proton, one proton, and one neutron. They use deuterium to carry out a nuclear fusion reaction, and our hydrogen bombs are much, much larger than atomic bombs. And so all of the bombs today that are utilized in nuclear warheads are all hydrogen bombs. They're all thermonuclear weapons. Now, in order to create the heat, we need a plutonium trigger. So we use a plutonium bomb. Now remember, a plutonium bomb actually uses conventional explosives to compress in some plutonium. So actually a thermonuclear weapon today is a regular bomb that causes a nuclear fission bomb, which then causes a nuclear fusion bomb all at once. The very first thermonuclear explosion was called Ivy Mike. It was Project Ivy, and this was codenamed Mike. It was the first staged fusion bomb, and notice the size of it, 10.4 megatons of TNT. So, Fat Boy was our bomb that we dropped on Nagasaki. It was 21 kilotons. Mike was 10,400 kilotons. So when we look at this, this was 495 times bigger than the bomb that killed 40,000 in Nagasaki, 40,000 people in one blast, and 70,000 by the end of the year. So 495 times bigger. This is what our staged nuclear weapons look like. This is a schematic of it. They use lithium deuteride as a fuel. And on top of a ICBM, you have a warhead here, and it has small nuclear bombs in there. Okay, so it would have all these nuclear bombs stacked up in here. And so a ICBM could have as many as 20 of these warheads. Each one of these is many times larger than what was dropped on Hiroshima or Nagasaki. And so this is the scary part of nuclear weapons today. Here's just an example right here. This is the Fat Man bomb on a skyline of New York. And then this here is Mike. 10 megaton bomb superimposed over top of it. You can get the idea. So nuclear weapons are totally ridiculous as far as a nuclear scientist is concerned. They're interesting to study, but they're not something that that any serious nuclear physicist is going to be a proponent of. So that ends this lesson. Now you guys can go and watch the video on how a thermonuclear bomb actually does its thing. It's a very interesting video, so check that guy out. And that's the assignment that goes with this lesson. I hope you're doing well and have a great day.